Lesson: Utilizing Python for AI scripting, syntax and libraries. Utilizing Python for AI scripting provides a robust foundation for developing sophisticated artificial intelligence applications. Python's straightforward syntax and extensive library ecosystem make it an ideal choice for AI scripting, offering a variety of tools and frameworks designed to tackle real-world challenges efficiently and effectively. By delving deeper into Python's capabilities, professionals can enhance their proficiency and leverage its potential to create intelligent solutions. Python's syntax is celebrated for its simplicity and readability, which significantly reduces the time required for learning and developing AI scripts compared to other programming languages. This simplicity does not come at the expense of power or flexibility. Python supports various programming paradigms, including procedural, object-oriented, and functional programming, making it adaptable to different AI tasks. This adaptability is critical when developing AI models that require iterative experimentation and refinement. The power of Python for AI scripting is further amplified by its rich ecosystem of libraries and frameworks specifically designed for machine learning, data analysis, and neural networks. Libraries such as NumPy and Pandas provide essential data manipulation capabilities, enabling the efficient handling of large datasets, which are often the backbone of any AI application. NumPy is particularly useful for numerical computations, offering support for arrays and matrices, which are fundamental in implementing machine learning algorithms. Pandas, on the other hand, excels in data manipulation and analysis, providing data structures and functions needed to work with structured data. For machine learning tasks, scikit-learn is an indispensable tool. It provides simple and efficient tools for data mining and data analysis, built on top of NumPy, SciPy, and Matplotlib. Its consistent and user-friendly API allows for rapid development of machine learning models, from pre-processing datasets to implementing algorithms and evaluating models. For instance, scikit-learn's ease of use makes it suitable for implementing classification, regression, and clustering algorithms, enabling data scientists to focus on interpreting the results rather than dealing with the intricacies of algorithm implementation. Deep learning, a subset of machine learning, has gained popularity due to its success in various applications such as image recognition and natural language processing. Python offers several deep learning frameworks, including TensorFlow and PyTorch, each with unique features and advantages. TensorFlow, developed by Google Brain, is renowned for its scalability and flexibility, allowing developers to build and train state-of-the-art models. Its ecosystem includes tools like TensorBoard for visualization and TensorFlow Lite for deploying models on mobile and embedded devices. PyTorch, developed by Facebook's AI Research Lab, is appreciated for its dynamic computation graph and ease of use, making it a favorite among researchers and practitioners for prototyping and experimentation. Real-world AI applications often require the integration of multiple components and technologies. Python's extensive library support extends to natural language processing through libraries like NLTK and spaCy. NLTK provides a comprehensive suite of text processing libraries that support classification, tokenization, stemming, tagging, parsing, and more, facilitating the construction of NLP applications. spaCy, while newer, offers faster processing and more advanced features, such as deep learning integration, making it suitable for production-level NLP tasks. To address real-world challenges, professionals can follow a systematic approach to AI scripting using Python. This approach involves understanding the problem domain, gathering and pre-processing data, selecting appropriate models, training and evaluating models, and finally, deploying the models. For instance, consider a case study in which a company wants to use AI to predict customer churn. By using Python, data scientists can collect data from various sources, clean and pre-process it using Pandas, and then employ scikit-learn or TensorFlow to build predictive models. These models can be evaluated using metrics such as accuracy, precision, and recall, allowing the company to make data-driven decisions to retain customers. Statistics reveal the growing demand for AI solutions across industries. A report by McKinsey Global Institute highlights that AI has the potential to create an additional $13 trillion in global economic activity by 2030. This underscores the importance of mastering AI scripting to capitalize on the opportunities presented by this transformative technology. Python's versatility and comprehensive library support make it an essential tool for professionals seeking to develop cutting-edge AI applications. In conclusion, utilizing Python for AI scripting provides a comprehensive suite of tools and frameworks that empower professionals to address real-world challenges effectively. Its simple syntax, coupled with a rich ecosystem of libraries, enables rapid development and deployment of AI models. By leveraging libraries such as NumPy, Pandas, scikit-learn, TensorFlow, and PyTorch, developers can create intelligent solutions that drive innovation and efficiency across various domains. As the demand for AI solutions continues to grow, proficiency in Python for AI scripting will be a valuable asset, equipping professionals with the skills needed to harness the power of artificial intelligence.